Hello to all our math friends out there. We thank you for joining us for this professional development on mastering the basic math facts. I'm Michael Elder, and along with me will be Shelley Alford as we get into this professional development. We thought maybe we would start with just a video overview here for this first session. We'll throw a couple things on Edmodo and we'll bounce back and forth and talk through what this professional development has to offer. So we thank you for being a part of this, and we look forward to learning alongside you and learning with you. There certainly is no one who has the corner on mastering basic math facts, but we're going to do the best we can to help add to your toolbox, and hopefully you'll be willing to share back with us so that each time that we do offer this professional development in the future, it gets a little better each time. So thanks again for joining us, and let's just kind of move forward here. As we begin and get started, I think it's important that we all realize that online professional development is new to some of us and it's old hat to other folks. Some folks think of graduate school classes. A lot of those are being delivered online now, and that certainly lends itself to being able to check in when you want to check in and leave it when you want to leave it. That's great for some folks. For other folks, that's a struggle because it's a lot easier sometimes to show up on a Monday afternoon for professional development and be there for the 2 hours, maybe do a little homework before you come back the next time. When we do these online professional developments, and this is really our first foray into a fully online professional development, at least for me, in the facilitator role, that is. So we know there's going to be some things that work really well. We know there's going to be some things that we will do differently in the future. We know that we're trying some technology that we haven't used before. This technology right now that you're seeing is Screencast-O-Matic, and that's brand new to me. We looked around for some ways to capture videos and capture our screens in ways that would be easy for you to interact with, and we think this is a good tool, but we may figure out there's a better tool in the future. So if there are things that you like about this, we'll certainly be asking you about that, and we'll also be asking you to be honest in terms of things that you don't like. So if this is a new format to you, we hope it's convenient for you, but we also hope it's effective. We certainly don't want to sacrifice things being effective just to be efficient. So as we work through this professional development, this is going to be delivered generally asynchronously. That's the big word that just simply means that we're not asking you to log in at any given time and saying, we're doing this online, but you have to be with us at 3 o'clock on Wednesday afternoons or something like that. So this is going to be delivered asynchronously, which means that this session goes live, I believe, September 8th, and you have until that next session time to watch it, do any of the responses to it, and that's all on your decision in terms of when to do that. So again, that's freeing to some people, and it's, oh my gosh, that's one more thing to remember for other folks. So I totally get that. That would be me. I'm much better when somebody says, just be here on Monday afternoon, but not everybody's like that. As a facilitator, I like this format in the sense that I can prepare this in advance. We can put it out there. Shelley and I can get together on and offline and prepare these things for you. What I don't like is I don't get that interaction with you, and maybe that's something you'll feel too, is our interaction is going to be online through Edmodo, and so it's going to be more in chat format than it would be if we were sitting in a professional development. You could say, wait, stop, let me look at that again. So we hope that by using this video format for things where it's appropriate, that'll give you a chance to stop, rewind, check things out. So again, some things we're going to like better than being face-to-face, and other things that we'll say, I wish we were face-to-face. So we get that. We do want to make sure everybody does understand that it's asynchronous, so you'll log into Edmodo, see where the updates are, and you'll work from there. We will try to have everything posted. If it starts on a Monday, then we'll try to have everything posted by that Monday morning, so when you're ready to check in, you can certainly do that. This professional development, although the standard course of study may say that math fact mastery occurs in the early grades, in the K-5 grades, we know that kids struggle with math facts well beyond 3rd grade, right? So we've structured this professional development that folks who are working with kids who need support with math fact fluency, that this is built for you regardless of your grade level. And especially if you work with struggling students and kids with exceptionalities, hopefully some of these tools and tasks will give you a chance to add to what you already do with those kids. And we look at how do we actually teach math facts versus how do we assess math facts. So we'll talk much more about that later. We do want to make sure that regardless of what grade level you teach, you are welcome with us. A few things just to think about. I've already talked about this just a little bit. Each session is meant to be about 2 hours in length. That doesn't necessarily mean that Shelley or I will be presenting for 2 hours. If we were in a face-to-face professional development, I hope we wouldn't be presenting for 2 hours, but rather that you would have chances to do tasks and then you would reflect on those tasks. So that changes form when we go online, right? So we might say, okay, watch this video, or we may even just have a post where we say, click on this, try this task, and then respond to that task through Edmodo. So the 2 hours will take a variety of forms. Sometimes, a lot of times, that part of that 2 hours will be working with kids in your classroom. It might be working with a neighbor's kid. It might be just reflecting on a task yourself if you don't have easy access to kids for whom the facts are appropriate. Whatever that looks like, though, it should equal about 2 hours a week. So if you would typically be in a professional development on Monday afternoon, like say from 3:30 to 5:30, you might want to go ahead and put on your calendar Monday 3:30 to 5:30 I'm doing Math Fact PD, or probably a better idea to say Tuesday or Wednesday, just in case Shelley and I take an extra day or two to get something posted on a given Monday. That could happen. Life does happen to us. So be thinking about when will you interact with this professional development in terms of getting your hours in during the week. So like we said, budget your time, set time aside. That's not always easy. Like many of you, it's usually Saturday morning when I get to these things. So you may find that it's a weekend time when you do it. We totally understand that. It's professional development, just like graduate school. A lot of times that happens at odd hours and on odd days. If you run into a situation where you just feel like, I really still want to do this, this is really what I need, and I like this, but I'm just struggling this week and I need a little bit extra time, let Shelley and I know, and we can certainly work with you on that. What we can't do, though, is say, let's let everything wait until December and then do everything in December and knock it out. The downside of that is it would be like not coming to a professional development and then showing up at the last session and saying, I'll stay until I catch up. Well, you've missed all those conversations along the way, and it's really not, it's not what professional development is meant to be. It loses the sense of the back and forth of conversations and the I agree with this, I disagree with that, we're going to banter back and forth. So if you're falling behind by a week, we can definitely work with that. That's not a problem at all. We will probably all have those situations over the course of the next 10, 12, 14 weeks, however long this lasts. But if you're falling behind multiple weeks, our hope is as we have this professional development built, we'll be able to offer it again maybe in the spring semester and hopefully each year, because we're all trying to figure out how do we help kids with their math facts. You will be asked to do some things yourself. By that, we simply mean that you will be asked to maybe complete a task and post a picture of what you did with that task. Again, we'll interact completely in that way through Edmodo, but some of those things might be new for you, and that's okay. If you have trouble uploading a picture or those kind of things, let us know. If you have trouble completing an assignment, let us know. We are glad to work with you. This is definitely all of us in this together. So you'll be doing some things yourself. You'll be doing some things with kids. It's hard when we're doing everything from adding with 0 all the way up through multiplying by tens. It'd be nice to say, well, give these tasks to your students. Well, that's not going to work probably unless you have a very wide range of students. And if you do, then use your kids for all those things. So at some points during this PD, we'll ask you to go out and find a student. That might mean you have to find somebody outside of your classroom. Might mean you need to go down to the second grade hall if you're a fifth grade teacher and get a student. It might mean you need to find a struggling student versus a high achieving student. So we'll work with you on those things, but do make sure that you realize that some of the value in this professional development is really interacting with kids and seeing, does this work with them? Who does this task seem to be more beneficial to? We'll try to make that as germane as possible, make it as meaningful as possible for you. And again, if you have trouble finding those students, just let us know. But do understand that we know you can't do it all. Right? There are going to be times that you may struggle with the time frame. There may be times that you just, I can't get to a second grade class right now. I'm doing 13,000 other things. We all get it. Right? We're all in this thing together. So just communicate with us. Let us know how it's going for you. And if there's a task that just doesn't work for 10 people, then we know, hey, we got to change the task. Right? That's what we do as teachers. So Edmodo, many of you, if you're in middle school, or especially 7th, 8th grade and up, you may have been interacting with Edmodo quite a lot. I know last year a lot of administrators used Edmodo as ways to communicate with staffs. Some did that more than others. We're all learning Edmodo as our learning management system. I'm much more fluent with Edmodo now than I was a year ago, and I hope that a year from now I'll be even more fluent. So I hope you feel the same. It is completely okay to say, oh my gosh, Edmodo is new to me. That's totally okay. So we're going to ask you in Edmodo, and we'll show you here in a second, both setting up a poll and then asking you to complete that poll. So let's flip over to Edmodo here. So let me pull up my Edmodo screen. I'm going to slide it over here so you can see it a little bit better. I apologize if this kind of bounces around a little bit. Right now, my screen is on the library. So let me go back to our Mastering Math Facts group. And here you'll see that welcome message. Hopefully you've already seen that and read that. That was just, I wanted to make sure we had that up. And Shelley and I wanted to make sure we had that up so that if some of you joined this group early, you understood we weren't going to be posting much until around September 8th. So you will see here that we can now put in a poll. Right? So the first question I would like to know, and I think Shelley and I would both like to know, is what is your level of comfort with using Edmodo? And by that, we're going to talk about personally, not necessarily with kids, but just, so let's give ourselves some categories. Let's say the first category is I'm an expert and have been using Edmodo regularly for myself and students. You can see all my typos here too. How about the next level is pretty darn good and have been using Edmodo for my own use. Let's add a couple answers here. Let's say kinda good. I like random categories, sorry. Kinda good. I've used Edmodo a little, but this will be, but I will learn some in this process. And let's make our fourth choice Edmodo. What is that? So if it's new to you, just go with that one. So now I can send this out right to our group, and so it'll be on your screen when you're logging in and looking at this. So some of you may see this before you even see this video recording. So I'm going to go ahead and send this, but I'm going to say, don't send it right now. Let's go ahead and send it on September 8th, and we'll push it out starting at about 8:30 in the morning. That way, it's not going to show up on the screen as I'm typing this, but it will show up for you whenever you're in the group. And I'm going to go ahead and send that. So we're going to ask you some things in Edmodo like this, in a poll setting where you can respond, but we're also going to ask you to do some tasks and reflect on posts, right? So I'm going to use this initial post that we put up a little while ago, just telling you the PD wasn't going to start until September 8th. You can, just like Facebook, right? You can tell us that you like that post. Sometimes it's nice just to tell somebody, hey, I like this. I don't need to say anything about it. It's kind of like saying thanks without having to say thanks. You can certainly reply to the post, and a lot of times that's how we're going to be asking you to chat back and forth. So hopefully replying makes good sense to you, and if not, it simply is a matter of clicking on the reply. Mine may or may not want to come up right now. No, it doesn't want to pop up, but it simply is a matter of clicking on the reply, typing your response, and saying, I really agree with this strategy. I can see that this would work with my kids who are struggling, or it could be, I really disagree. I don't think that this would ever work with kids in my grade level. I can't see myself using this. Either response is fine, right? The key, though, is to kind of get that conversation going back and forth, and that's hard even in face-to-face professional development, but online, sometimes that's easier, sometimes it's harder. So be willing to have those critical conversations in these chats. We talk with kids about digital citizenship and how to have those conversations politely but honestly, where you say, well, actually, I have tried this with my kids and it does work. And that's not meant to be offensive, right? It's just meant to be part of the conversation. So as we reply back and forth, I think we have to go into it with the understanding that we're only making comments, you're only making comments because it's for the good of growing, right? And it's for the good of us getting better. So let's just talk, so that's replying. Let's talk a little bit more about Edmodo 101, and I apologize if you are one of those expert folks. This is where you can kind of zip through this part of the presentation. So you will see I have a variety of groups in mine, and you have a variety of groups, and our groups can be totally different. Right now we can see that we have 5 members in our group, and hopefully as people sign up and they register, then that number goes up more and more. We can go and look at just our posts, which is where we are now. We can look at our folders. So you will have a folder, or actually you already have a couple folders in here that Shelly and I have set up. One that will have the different resources that we use for addition and subtraction during the first part of this PD, and then the multiplication and division pieces that will go down here under multiplication. So you will see all those appear in the library. Within this library we have one of the PowerPoints we're going to look at here in a few minutes. And we also have NCDPI's resources of fluency through games. So this is where your library lives up here on your screen. So if you want to save anything into your own library, you put it up there in the library. But as long as you're here in the group, you can just go to the folders link. And then the folders will bring you to what's just assigned to Mastering Math Facts. So these are, in essence, kind of like the binder inside this course. You do have the opportunity, we might toy a little bit with Snapshot, but probably not, to create assessments for students using Snapshot. So that's the other option here across that main screen. Those are the biggies. You do have a calendar in Edmodo if you haven't used that before. Right now, mine isn't showing, I think, because I'm on this partial screen, so I apologize. But normally, over here, you would see your calendar. I don't know if I can get to it up here. Oh, can't get to it up there. You would see your calendar, and you can click on your calendar. So if Shelly or I make an assignment and say, this is due on September 30th, when you submit that assignment, it communicates back to us through our progress. But you can also look on the calendar and see, what do I have due that's coming up? So if you're using this with students, obviously that helps them with when is this homework due and where do I turn it in. But the calendar option is very nice for keeping up with things that are coming up that are due. Those are probably the main things that we'll use in this group. There are definitely options to use apps and some of those kind of things within Edmodo. I don't know that we'll use a whole lot of those, but we may find ourselves using some of that. So let me slide this kind of back over here out of the way. Hopefully, as you've watched this, you've had a chance to do your level of comfort, or you will here soon. And let's talk a little bit about our focus. So the focus here is split into 2 parts. Shelley and I are not necessarily just dividing this up, but she is going to lead the addition and subtraction part of this professional development. And we will both be on the Edmodo group and be able to chat back and forth with you. But you'll probably hear a lot more from Shelley in the first part of this from September 15th till about October 20th. And then I get to pick up starting October 27th through December 8th, looking at multiplication and division. The plan, timeline-wise, again, go back to talking about the calendar, the plan is that you would have all your work completed before we leave on the December break. If that's a problem and you need into January, that's fine. We don't have to turn in sign-in sheets until mid-January for this first semester professional development. But if you're done, if everybody's done before December, then we can turn that in December and get all those CEUs awarded. So this professional development is built around 2 math content CEUs. So if you do the entire course, then that's 2 math content CEUs, which is hopefully valuable, not just in the CEU world, but also valuable just in the sense that hopefully it's good content. And we're enjoying putting it together, so hopefully you'll enjoy being a part of it. Now you might ask a little bit about why, or you might wonder what resources we're using and why we're using them. So let me show you a picture. You may have seen this book before. I apologize for the glare on it there. I should have put the little screen down on top. But this is the Mastering the Basic Math Facts was published, I believe, a year or 2 ago by Heinemann. And Susan O'Connell and John SanGiovanni, they have a ton of math resources out there that they use, or that they've developed, I should say. And when this one came out, we had the, I don't know what you call it, like the moment when you say, that's what we've been looking for, right? So let me zoom in here just a little bit in case you're trying to see the book. But we know that there's a struggle out there, not for assessing math facts, we all know how to assess them, but for what do I do when kids are struggling, and really what do I do in advance so that kids don't hit the level of struggle that they're currently experiencing. So when we saw this come out, we ordered a couple and we said, well, maybe it'll be good, and then we started reading them and realized, no, these are actually pretty solid. So our focus is going to be on these 2 books. We'll talk about some other resources, of course, but we're going to focus on walking through this book. So this is kind of a book study without being a book study. So as we work through the text, I don't know how well this will show up on your screen. This is the multiplication division book. You will notice that they really key in on us understanding that there are these big ideas in multiplication and division, and the same for addition and subtraction, that if we can help ourselves build this really strong conceptual understanding, that benefits kids far beyond things like Mad Minutes and things that we've been doing for generations, right? So, but have kind of got us to where we are, and so we say, okay, we got to do something a little bit different because we're looking at the results we're getting and saying that isn't what we really want. So the book is going to take us this, and again, just looking at the multiplication one because it's right here in front of me. We take a very direct approach and a very research-based approach in terms of how we teach the multiplication facts. We might typically have gone facts 0 through 10 in that order, but that's not what the research says works for kids. So this book is set up in the same structure that most of the research points to, starting with things like doubles, working on tens, those kind of things. So the book is set up in that order. That was one of the things that I believe that Shelley and I both liked. And we have ordered several of these texts, so if it's something that would benefit you and you would like a copy, we'll be asking you for that information as we work through this professional development too. We certainly want to equip you with all the tools that you'll need to be successful in this. So you'll see a lot of us using the Elmo over here as part of this, and hopefully that gives us a chance to share what we're looking at. Gotta click on the screen, there we go. So there are tons of other fact resources, right? Most of you, if you've been teaching a while, you probably have a cabinet full of different ways to assess math facts. I know growing up, many of us went through math minutes, and there's nothing wrong with those things. We're going to look at those here in just a minute, but well, we're going to really focus on the teaching of math facts, with assessment of math facts being a component of that, not the driving force of that. So NCDPI has a great resource, and hopefully all of you already know about it, but if you don't, we're going to look at it here in just a minute. And it's already in your folder, as you saw just a minute ago when we went into Edmodo. So we're going to look at that resource. There are also lots of online and print resources. This is certainly not the only text on math fact fluency, so you are going to bring a wealth of knowledge to this. However, for a 20-hour professional development, Shelley and I felt like we really needed to focus using one resource, so we're going to stick most of our teaching will be focused on the texts. However, we know that in the conversations, we'll all be bringing in our other resources and saying, well, have you tried this? And how about this game? How about this task? So please do add those things in. It's just that our foundation is going to be this text of mastering the basic math facts. There's lots of apps out there too, right? And probably many of us can admit to either getting lost in searching through apps or searching through Pinterest for ideas on ways to teach these things. But what we want to come back to is what's the core of how we teach these things, and what do we really want to do with kids, and then if we need to add to that core, we do, and if we don't, then if that's what's effective with most of our kids, then let's go for that. So hopefully that will make sense to you, and hopefully it'll streamline some of our teaching pieces. So before we get into what is fluency, I'm going to put this back down again, and we're going to grab, there we go. We're going to grab back to our Edmodo group. And remember we said that this is in your folders. I think I accidentally put the file that we're looking for. Let's reset here for a minute. And I believe I put this in your folder for the multiplication session. I got to bounce back into our group. There we go. There we are. Multiplication in the multiplication group. So I'll try to pull this out and put it in your main folder. But this document has been around, I believe, for 2 years, about maybe a year and a half, building conceptual understanding of fluency through games. So what Kitty Rutherford and her team, Denise Schultz and their team at DPI did was pull together some of the most common and useful games or activities that can be easily set up in stations in classrooms. So this is an addition, just as one of those examples, as we talked about, that there are lots of ways to get at teaching math facts. And by the way, these are nice things for that 5 minutes in the morning or 15 minutes in the afternoon when you're waiting for buses to get there, that you can do repeatedly. So here's the whole list. I won't go through the entire document. It's rather lengthy. But the way this one is structured is simply that it gives you the board game, so you can print it out. You can laminate it if you want to. We all like to laminate some good stuff. And as you do that, you can look at the rules. It'll tell you if it needs like counters or things like that. Gives you some blanks to make your own. So not all the resources, but all the game boards are in here. Typically, most of them will take like a paper clip to make this into a spinner or something like that. But again, very, very quick, very easy resource to use and developed by DPI. So it's got that depth and the rigor to it that will hopefully help us all serve our kids. So again, that one's in your Edmodo group. Let me just slide that over here to the side. And we'll come back to our presentation here. So Kitty Rutherford and Denise Schultz, I believe it was in 2013, put together a presentation on memorization of math facts versus automaticity of math facts, perhaps versus conceptual understanding. So all these things that were going around, and this was timely at that point. For those of you who were around at that time, that's when the legislature added that students would memorize math facts, and that would be in our standards. So it became a question of, well, what does it mean to memorize? And So they created this presentation, there you go, November 2013. I pulled out a couple of the slides. This is available in a webinar, so if you want to listen to a different voice, I know you're having to listen to me for quite a while today, but if you want to listen to the full thing, we'll talk for a little while about this, but we certainly won't go into the depth that Kitty and Denise did, and they do such a nice job of explaining, oops, pull that one back up, of explaining what they mean when they talk about math facts and fluency. So let's go ahead here and just look through what DPI gives us some guidance on. So we talk about computational fluency. We'll talk about strategies versus algorithms. For some folks, algorithm might be a word that you say, I think I heard that somewhere along the way. And that's simply, we talk about the algorithm that's typically defined as the most efficient way to get to an answer. So when we think about 23 times 17, for example, when we think of the algorithm, we're thinking about taking the 7 times the 3, then the 7 times the 20, then working through the algorithm that most of us probably learned in elementary school, as opposed to a strategy-based approach where we're teaching kids things that will work even if I forget, wait, am I supposed to multiply this one times that one, or is that a 10? Is that? So we know that drill with kids. And then we talk about drill and practice, memorization, automaticity, and then the power of time tests, or what do time tests do to kids. So let's look at computational fluency, and we ask you to think about this one. What does it mean when a child has computational fluency? What do you see? What do you recognize? What kind of things would you hear in a classroom or in your classroom when a child really becomes fluent, whether that's in addition, subtraction, multiplication, division? What does it mean when somebody becomes fluent in that operation? So take just a second, think about that. I'm going to flip over into Edmodo, and we're going to put a post up there and ask you the same question. So you can just reply to the post. So let me jump back over here into Edmodo, and let's add that question to our group. What does it mean to have computational fluency? So there's 3 questions. You might like all those, might just want to respond to one of them. Again, I'm going to tell this to send it a little later so that you will see it when you log in. There we go. So let's think about what computational fluency might be based on some other folks' definitions. This is from our national organization, from the National Council of Teachers of Mathematics in PSSM, the Principles and Standards. So you see some key words here, right? That you're efficient, you're accurate. So there's something to do with speed there and precision, right? That it's not just fast, but it's fast with some level of accuracy. But then the second part demonstrates flexibility in computational methods that they choose. So fluency has more than just being efficient and correct, right? It's also the ability to be flexible. The ability to say, I know how we do this when we have 2 digits times 1 digit. What does that mean when I have 2 digits times 2 digits? Or I know for addition, I know how adding 1 digit and 1 digit works, so can I use that to help me with when I add 2 digits? That's an additional level of fluency that maybe isn't typically defined. I'll give you a second to read this. Again, this is from NCTM. Now, I would dare say that, oops, there we go. I would dare say that this piece right here, the structure of the base 10 system, is one that gets a little bit of a knock in the public, perhaps, when we're asking kids to think about different ways to add. Some folks really get that, and they understand that, hey, that's how we've counted back change at a register forever, right? When you buy something at Walmart, or you buy something somewhere and somebody is still counting back change to you, they don't, if you pay $25 and the thing was $21 and so many cents, what do we typically do? We don't subtract those two things, right? We generally count them up, right? So if it was, I paid 25 and it cost 21.50, then I would say, okay, and 50 cents gives you 22, and then 23, 24, 25. So we've been doing these kind of things in real life situations for a rather long time. However, sometimes when we start teaching these as strategies, some folks think, oh, it's just easier to do let's just get back to doing the traditional algorithm. And maybe there's some merit in that for some kids. I'm not saying there isn't, but fluency talks about being able to manipulate that base 10 system, the ability to make it make sense for you. So Hiram Bass, in his texts, talks about computational fluency entails bringing problem solving and understanding to computational problems. So maybe we need to separate out. There's computation, and then there's computational fluency. And this becomes really apparent for those of you who work in middle schools and high schools. When we get into high school especially, but also middle school, that being computationally fluent means that I can take some things that I may or may not remember from before and make them work in new situations. So math not existing in a vacuum, right? The math actually takes place in a real world setting. So when we think about a problem, we understand, oh, this is how I could make these fractions work, or this is how I could make these facts work. So that then begs the question, okay, so if computational fluency is our goal, what do we do to develop that, right? Our traditional approach has been to drill and practice and drill and practice and drill and practice, and there's nothing wrong with practice and repeated practice. In fact, it's needed to have repeated practice. However, you need both. Kids that get repeated practice without getting to the conceptual understanding forget those facts, and we see that year in and year out, right? That a student may show mastery, say, at the end of third grade, and then they come to fourth grade, and the fourth grade teacher says they don't know their facts. So we start all over again. Then we start all over again in fifth grade and sixth grade and seventh grade. And it's definitely not for any lack of hard work on behalf of any of us as teachers. But what it shows us is the kids really didn't have a depth of understanding that allowed them to hold on to that knowledge. And then there's some kids who just never really got to that understanding too, right? So we need both, right? The second bullet here is, to me, is so key. The understanding without fluency can inhibit problem solving. Because if I just understand the facts and then I'm given a problem that gets to the root of those facts, like maybe I need to manipulate those numbers a little bit, well, now I can't do that because all I know is that 7 times 3 is 21. And I don't understand that I could have done that in a couple different ways. I could have done 4 times 3 and 3 times 3 and got the same answer. So the more conceptually our kids understand facts, the more they're able to play with them and work with them. Again, just reiterating some of those points. So, like I said, we're not going to dwell on these. I like this slide because I always forget. What do our standards say? How far will kids go in different grade levels? This is nice for a parent too. This might be a nice newsletter piece. Where were you in kindergarten? Where are you by the end of 6th grade? So we can see we start off relatively slow, but the intent of starting off slow is that there's great depth there, that kids understand everything about those numbers within 5. They understand they can pull them apart, they can play with them, and then the same within 10. Because once you have that, then the ability to expand up becomes relatively easy. However, if we don't have that really strong foundation at the very early grades, then we're going to struggle for a long time. And we see that, and I'm sure you see that on a daily basis. This question comes up fairly often. Folks in their honest moments, and I was probably one of them at some point, and say something like, "Come on, it's so much easier just to teach them that 4 plus 3 is 7. True. And that it's so much easier if I teach somebody that 10 plus 8 is 18. Can't they just memorize the simple facts and then we can just move on? What do you think? Can they? Do they? Do kids memorize them? Do they remember them? What about the standard algorithm? So we're going to explore this a lot as we go through the PD, so I'm not going to dwell on these slides. But we are going to just lay the foundation today for the difference between strategy versus an algorithm. Right. Hopefully, our instruction focuses on both, and we'll look at how we do that. We'll look at some of these strategies as Shelley takes us through addition and subtraction. Many of you have probably been doing these strategies for a long time. It's one thing to be able to do the strategy, and hopefully you will add some great learning tasks that get us at these, and hopefully we'll add some learning tasks to your bag of tricks for these too. Same thing with multiplication and division, that there are certain things that if kids understand these general concepts, they can apply them just about anywhere. Given enough time, this is an interesting discussion. If we were together, it would certainly take some time to kick this thought around, right? That given an opportunity, that kids will invent methods to compute. I don't know in a typical classroom that we have a whole lot of time to do that, but generally we as humans come up with ways to make sense of the things around us. They're not always accurate, but we'll figure out some ways. Kids, given enough of the basics, we'll figure out ways to make sense of some things, and we'll look at a little piece of data here in just a second to get at the heart of that. So let's look at this for a second. So this takes a minute to kind of digest. So give yourself 30 seconds or so here to look at this. The reference here at the end of the slide is for Constance Camille, and she's done a ton of research with young kids and just people with mathematics. So this was one of the many tasks that was given to early second graders, right? So add 7, 52, and 186. So given to 3 classes of second graders. In the first class of 17 kids, those kids had all been taught an algorithm. So this is how you add 3 numbers together. We're going to keep the columns, we're going to keep them organized, we're going to do all this, right? So that's that class. Then the middle class was taught some algorithms, right? So we're talking about this group here now, right? So 19 kids, they were taught some algorithms kind of at home, right? So not in a traditional school setting. And then finally, we've got this group, the third group, right? And in the third group, they hadn't been taught anything about how to do this. So these 20 kids, they just knew what they knew about addition, but not necessarily anything about adding 3 digits or lining things up. So if we start looking at what did these kids then do? Right? So the kids who had the algorithms, these are kids who were taught it, obviously the correct answer is right here. Right? So for all three groups, the correct answer is 245, because that part of the math never changes, right? So we add these three. We notice that the kids who used an algorithm, the variety of their answers is kind of interesting. So they came up with all kinds of interesting answers. And we could probably break these down and try to figure out what they do. And did they line them up? Did they just put a... And that would be a fun task at some point, right? The kids who had some algorithm taught at home but didn't necessarily have one set algorithm that they were taught and told that's how they had to do it. The spread of their answers, right, is a little bit slightly narrower, but it's still pretty broad. However, about twice as many kids, and again, we're talking about 17, 19, and 20 in these three different groups, about twice as many kids got this correct, right? So still not a lot of kids. And then in the third group that hadn't been taught an algorithm, look at the spread of their answers. Relatively narrow, right? Like their lowest value is 138. And again, we can look at why did they answer that, but it's just interesting that they're much more clustered together. So we might anticipate that even though it's 45, so about half of these kids, so 9 of these kids got the answer correct, a couple of them are probably just addition mistakes, right? And then we still have some kids who are just doing something different, right? And we can compare, do any of these have the same? So is it important to teach an algorithm? Well, I don't think we want to say we're not going to teach an algorithm, but do kids make sense of math in ways if we don't get in the way sometimes? I don't know. This data seems to suggest something there. And I think this is kind of an interesting piece when we start looking at asking kids to do something that they may not know how to do. And that gets to our first math practice, right? Perseverance and problem solving. If you've been in any of our math PDs or any of DPI's math PDs, it's always fun to look at a problem like this. We say, okay, what is 456 plus 167? How do you solve it? Some of us right now are trying to twist the numbers around, right, and get the 7 into the 6 and the 6 into the 5 and the 1 into the 4 and get our columns in place. Some kids are going to do that, but do we think that kids do that innately? Probably not, right? So we look at different strategies, right? Different strategies that kids use, some that you might teach to kids. So again, you see the reference here to the variety of different ways to come up with an answer. We're focusing on the basic math facts, but you can see this is where they all lead, right? This into these bigger problems. We're not, I hope we're not knocking the standard algorithm. We're certainly not saying get rid of it. We're just simply saying that it needs to be based in something, right? Kids need to understand where it comes from. And some, for myself, and probably for most of us, we weren't necessarily taught where it came from. We were taught how to do it. And for some of us, maybe because we're good memorizers or because we figured out how it works, we were able to remember it. But we know that that's not the case for all our kids. So we've got to think about what works for all of our kids. So again, just flipping through a few of these things. Drill and practice. Is there something wrong with drill and practice? You may or may not have seen some students who have some pretty good math anxiety. That isn't always the result of drill and practice. Sometimes that comes from the messages that they hear in class as well as out of class. But does drill and practice help kids learn, or does it impede their learning? So that's really the question that we want to answer over the course of these next few weeks. We know that the things that we do with kids impact the way they learn and what they learn. That's what teaching is all about, right? So what we want to do is give kids that chance to really connect with the math, to really think about why do we line up these places and where does that decimal come from? Not just because we say we always put the decimal on the right and then move our numbers over. but it has to do with the values that those digits represent. So when we think about drill, we're going to talk about meaningful practice, we're going to talk about purposeful, we're going to talk about thinking about talking out loud about thinking strategies. If you've had a chance to do anything on any professional development on number talks, that certainly builds out of this same line of thought. And Van de Waal and Lovin here in teaching student-centered math, this one's a little bit tricky, right? Because we know at the end of certain grades we've got to get kids to a certain place, and so on one hand we feel this tug to get them there, and I'm only going to get them there if I make them practice it, and maybe there's some truth in that. But Van de Waal points out that kids really shouldn't be doing fact practice or drills until they know their strategy, or until they can apply their strategy to what they're doing. So hopefully we can build up their strategies and do that in as effective and efficient manner as we can, so that they have the tools they need. So memorizing facts, using flashcards, those kind of things, nothing wrong with those if they already have a strategy, right? But if they don't already have a strategy, then we're just trying to memorize, and that's not going to last, right? So we'll talk about memorization. Again, this is the legislation about memorization. We're thinking more about automaticity than we are about just memorization. Yeah, I'm just clicking through some of these. There's some great information in here, but we're going to spend a lot more time with this over the course of the professional development. However, this is all, again, and all credit to Kitty Rutherford and Denise Schultz for developing this. So this is one that sometimes we would spend a lot of time on if we were sitting together, is, well, isn't it faster to just memorize? And the data doesn't seem to support that, right? So at this point, it's probably a good chance to pause and say, all right, so there's some things that I probably do that I could tweak. There's some things I might just need to throw out. And there's some things that are right in line with what research says works. So as we work through this PD, what we want to hopefully do is enhance what you already do. And as any good practitioner does, we look at things and say, probably shouldn't do it that way anymore. And that's not judgmental, or it should, hopefully it's not judgmental. We want this to be as safe a place as we can. We've all made lots of mistakes. I certainly have made kids do enough math fact practice that now, going back, I would say, well, I don't know that really got me the results that I wanted. But there were also some things we did that were in line with this. So what we want this professional development to be for you is a chance to reflect and a chance to hone your skills. So as you have things that hopefully don't feel offensive, but may feel threatening, maybe is a better word, you may say, please feel free to bring those up. We're not going to be offended. This is just math, right? We want to know when things are challenging. We want to know when things are supportive. So please share those. Again, to give credit where credit is due, this presentation as well as a ton of math resources are on the Math DPI wiki space. So if you aren't familiar with that, it's a great place to spend a little bit of time to make sure you know what kind of resources they have. Kitty's and Denise's information is right there, and they say thank you for all that you do for their kids, and I say thank you too. So I'm going to jump out of this. Remember, that presentation is in your Edmodo group, and again, it's just in the folder. So you can just go to the folders, and in the folder for multiplication, although I'll try to slide it out into the big group too. So you've got that presentation, and you've got that information, and thanks again to DPI for having that public for us. That gets us to the end of our piece here for session 1. So we're right at about an hour on this video. You have a poll question to answer. We'll have a couple posts in Edmodo, both the ones you've seen here. We'll ask you probably to introduce yourself to one another and to us, so that we know who all we're talking with out there. And we encourage you, again, to not just post because we're asking you to post, but post questions that you have. Make this, hopefully this becomes a really good interactive group, and hopefully it's something that not just you, but people in the future will benefit from as well. So thank you again for your time in watching all this, and we will see you next week as we begin our focus on addition and subtraction.